Hi, da-da-da-dun. So today we're going to go over a very interesting episode of Algos in 10, episode 4, or as you know it, The Legend of Zelda. This episode will go through a more complicated version of Divide and Conquer. We have Link shooting bows and arrows to kill some Armos Knights, or aka circular recursion. Make sure to subscribe, and also, if you like Legend of Zelda, Breath of the Wild Part 2 is coming out very soon. It's an amazing game, and Zelda actually taught me a lot about recursion when I was younger in computer science. Let's get down to business. If you want to save Hyrule and also really enjoy Algos in 10, make sure to subscribe, because otherwise Ganondorf will come back. Uh-oh. In this episode, we're going to go over some very basic use of the DFS, or the Depth First Search algorithm, to find the best way for Link to use a bunch of arrows to kill the Armos Knight, including the last red one, which stomps around randomly and for no reason at all. If you've not played the game of Legend of Zelda, also, fun fact, it's actually MP complete. Check out MIT's Eric Domain for more information. So in this episode, we have basically another form of divide and conquer, this time with something called a circular rotation array. So in this problem, if you know from the Eastern Palace, you have a bunch of Armos Knights, which I draw very crudely over here. So you have Armos Knights from basically a range of several different values. So you have Armos Knights from M1 to MN, where of course MI is that big, mad, red Armos Knight, which basically goes crazy near the end. If you've not played Legend of Zelda, this is something that probably you should look up in terms of Wikipedia or something like that, just to get a familiar understanding of the game. Anyways, you have a bunch of Armos Knights in a circle, and then you have good old Link over here with a little dunce cap. And then Link over here has a following weapon to slay the Armos Knights. Very similar to that of the Jack Sparrow rum and the bottle of rum and the hearts. Link can systematically attack any of the Armos Knights with a bow and arrow. Or in this case, he has basically A1 to N arrows. In this case, we have also, in terms of heart, you know from Legend of Zelda, Link is hearts. So he has 1 heart to like H hearts total. And for those hearts, you want to make sure Link doesn't die, so H1 to M hearts. In the case that you have H of M equals M of N, that's when Link dies and the game is over. Game over. So you want to avoid the game over case when Link dies. So how do you avoid doing that? Well, you can use an algorithm from graph theory called Depth First Search, or DFS, to solve this problem. Now this is strange, right? You would not normally think about using DFS with a problem like this for divide and conquer, but computer science has its very interesting applications, and here's one of them. To apply the DFS algorithm, let's go over a very simple example. Let's say, for example, in this case, we have Armos Knights nodes Armos Knights nodes M1 to MN, but this time it's like in a circular ring data structure. So let's say for a simple case, N equals 4 for now. Let's just say for simple case, just to build intuition for the problem. And you have good old Link over here, ready to save Hyrule with his bow and arrow. In this case, you have arrows A1, A2, A3, and A4. Well, using a divide and conquer algorithm, you may want to try slay the knights sequentially, right? So the brute force would be pretty simple. It'd be just simply slay each knight from A1 to A4. And that is literally it. But that only works if you have M of N equals to A of M. If it's less than that, you're in trouble, because then you have another Armos Knight M5, which is the red one, and that will kill Link, and that is not good. So you can already see brute force is not a good solution to this problem. So let's try divide and conquer with some DFS instead. Applying divide and conquer is actually pretty trivial. So you do the good old divide and conquer algorithm. So divide is pretty simple. You first partition the Armos Knights, M1 to MN. Sorry, partition Armos Knights. Partition Armos Knights M1 to MN in terms of the circle into K groups. We then also hash the positions of each partition of the Armos Knight. And we're not done yet. We run DFS. So already directly just based on the divide step, we run DFS on the graph algorithm. So why do we run DFS directly? Because DFS has the following benefits. It's called depth first search because we use something called a priority queue, a data structure that should be very familiar for computer scientists. So we use something called a priority queue, which is great for this problem because you can actually say what the order of how Link slays the knights. Because if you don't have a priority queue, you have no idea how Link is going to slay. Sorry, how Link slays the knights. How Link slay knights. Running out of space, sorry. How Link slay knights. Okay, so we know we have to use DFS for this particular part of the problem. So let's now add in the conquer step after saying we used DFS. The conquer step is actually really trivial in this problem set, unlike the last one, because all you have to do is only two main cases. So conquer step is pretty trivial. I'm actually going to switch pen colors for the conquer step because it seems to be a better idea. So for the conquer step, I'm switching to black pen now. We basically put each position of the knights of the Armos Knights in an M1 to MN array. Right? And then you put the nodes that represent each partition as part of a G equals VE graph for DFS. So you can abstract away with the graph data structure. By the way, in the comments, I'll actually have a tutorial for how the graphs work with DFS if you want more information. So obviously V in this case would be the connection of knights. M1, Mi, and M of I plus 1. Well, guess what the E is going to be? Basically the unweighted directed edge of the knights, slaves. So unweighted directed edge of the knight. So that's it. That's how you set up the first part of the conquer step. The second part is basically very similar to the previous Egyptian skyline. We have basically two cases situation. I'm going to show it very soon. So let's say we have the case that Link is successful. So let's say Link has arrows. Let's say for now A1 to A of N that hit at least one of the Armos Knights, one of the M1 to MN Armos Knights. Remember, this is a circular queue, so Armos Knight can't really move anywhere except in a circle or in a line. Because if they move otherwise, this problem gets NP difficult and I don't think the producer, Miyamoto, wanted that from Nintendo. And this is from the bow and arrow weapon that Link has to kill the Armos Knights. Otherwise, if Link does not hit, so let's say Link misses with A1 to AN arrows, then he loses, obviously, because the Armos Knights gets very angry and tries to stomp on Link. Then he loses up to H1 to HN of hearts, which is bad. Which means in this case, you have constraint that H of N is equal to M of M, but less than equal to A of N. So in that case, we would not add an edge in the DFS. Sorry, not add an edge in the DFS. Or in the first case, we would add an edge. So we add an edge to DFS. You can see how we're abstracting away the algorithm with DFS in terms of divide and conquer. This is a very unusual solution to an interview problem, but it'll show you know both DFS and divide and conquer at high level. Now let me wrap this up with the combine merge and runtime, and let's have Link save Hyrule. Wait a minute. Princess Zelda actually said one more reminder. We forgot about the Red Knight, the knight that Link is gonna have to kill last. So with the Red Knight case, we have to be very careful. You can still use up A1 to AN arrows, of course, if you have any left. But you have to be careful to make sure that there's no other Armos Knights left in terms of duplicates, because sometimes Ganon can make duplicates, which makes things difficult. So make sure for each M of I to M of I plus 1 knight, they have already been slain, which means they are not existing in the DFS graph. Oh, also, because it's a circular thing, you also have to consider M of I to M of I minus 1 as well. And of course, make sure that H of I, the number of hearts Link has, is greater than 0. Because even with din 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 din, 1 heart or the warning beeping sign in Zelda, you can still fight as Link. There we go. That will end the conquer step, finally. And this formally means we have reached the end node of DFS as well, which is what you wanted to do. You want to basically traverse the graph GVE with DFS given divide and conquer. You'll see very quickly why graph algorithms are very important later in these Algos in 10. So yeah, we have now finally finished the conquer step, and we can now bring in the combine merge and runtime. So for the combine merge slash runtime, we basically conclude the divide and conquer. We conclude the divide and conquer by back traversing, which means we basically go backwards by backtracking or traversing the DFS. And then print the order of knights slain. And this is actually related to a leak code question I had regards to like finding the good apple in the tree. I'll show you the leak code question in the links in the comments. And finally, for the runtime, this thing is pretty much divide and conquer quintessential O n log n, because we use O n to traverse all M1 to Mn Armos Knight nodes with DFS. In addition, we do O log n because we're trying to split attack for Link. Split attack for Link with bow and arrow. And that is it. That is the finale of the divide and conquer algorithms for Algos in 10 in terms of like just general using divide and conquer. Next, we're going to go over a new topic, which is going to talk about happy numbers. That next new topic will actually talk about the cube of happy numbers and also be able to know what as a number is considered happy, which is also a LeetCode problem that's modified a bit. Then for part 2, we're going to go over some data structures such as medians and medians with the chocolate factory, some AA trees or binary search trees, hash tables, and of course a hashing ADT, abstract data structure. So from now on, the algos in 10 will be a little more complicated and a little more convoluted, but I'm still trying to simplify the problems easy enough for you guys to learn. So anyways, this is Algos in 10 episode 4 with Jason Liu, and make sure to subscribe and have a nice weekend.